Welcome back. And this is the last part of the series, and you can see I have all finalized the architecture diagram. It will also help you understand the importance and significance of the architecture we generally build before we start developing any solution. And now you can see how we gradually build this solution from developing the secure API calls from all the way to a complete solution that can now extend to or scale up to enterprise level, where we have multiple Lambda function, and based on the parameters through our API gateway, we can identify which function we need to call from the Lambda function, and every call is going to be authenticated. There's only one bit which is remaining in this solution to integrate the AWS Secret Manager. And what AWS Secret Manager does, it stores the sensitive information in the secret, which is obviously the secure store. You can call it, or secure repository, where you dynamically retrieve the information in your code, and you provide that information as part of the authentication or authorization mechanics which have been embedded part of your solution. So in this case, obviously, if you remember, we are extracting the JWT token from Cognito. So in order to do it, I need to provide client ID and client secret. Generally, these two, if I can secure them, that's gonna suffice for my code to be secure. But I would go one step further, and I'll save the domain URL, client ID, client secret, and the fourth one is scope. So I don't want to keep any static value into my Lambda function. Everything I want to extract from the secure store, and then I'll do the call to the Cognito for the JWT. And I think this diagram is now much clearer compared to the first version, and I purposely did it in this way because I want to show how the architecture evolved. And if you remember our discussion, that generally devs wants to start the code once they understand the requirement, but it's always good to have the initial version of the architecture in your hand. So once you start building your solution, it can align with the base architecture. And obviously the architecture is not going to be static. It will evolve over the time. Like if you remember, we have seen this architecture evolve from first stage all the way to the final stage where we are closing it off today, right? And now you can even see the flow, how the whole flow works. So similar in any kind of solution, whether it's going to be the pure software dev solution, or it's going to be an analytical solution, or it's a data warehouse solution, or ETL pipeline. Every solution start with the base level architecture, and then it evolves over the time how we progress with our solution. And once new thing comes up, we adjust our architecture, and obviously in correspondence the dev adjust their solutions as well. So both will align, because at the end, once we finish the solution, it can be easily audited again against the architecture diagram. And even sometimes it's very helpful for the project managers to understand the solution or the progress of the solution from the diagram, and as well as the business user who can look into the diagram and understand your solution, right? Last but not the least, it also show you the flow of the information or flow of the code, how you are going to divide, and where it can be built in parallel, or where it create a dependency from one module to another, right? So if I'll take this example in this solution, you can see, so the very first thing, I can still build my code, but I know that in order to finalize it, I need the secret manager to be set it up and store my secure information. Without that, I cannot release my solution into production, right? So it create a dependency, and I know I need the time of my infrastructure team who's gonna help me to set up this secret manager. These days with DevOps, obviously the devs work in the operational capacity, and they set up everything as part of the code. But just to give you a quick example, how you can identify where you have a dependency on the infrastructure and where you have the dependency on your code or within the modules as well. So coming back to this architecture, the very first step, we're going to retrieve the client credential and domain URL from the secret manager, and I'm going to show you in a moment how we can store it in the secret manager. And once we get that dynamically through the Lambda function, we're going to pass it again. From that point onward, everything will remain same. Like we're going to pass it to the cognito to request the JWT token. In return, we're going to get the token. If the token has been received successfully, we're going to pass that token to API. API is going to validate this token back to the cognito. If the token has been validated, it's going to actually call the Lambda function and return us the value. So that's the overall flow for this solution. So now we have seen it in the diagram in description. Let's jump back to the virtual machine and see if we can make the similar processing into our Lambda function. I typed my password incorrectly. So now, just to show you how you can create, so there's a service called AWS Secret Manager. If you go in here, you can create a new secret for your solution, and you can see it generally stores all the database credential like username and password or keys, whatever you want to store. Secret Manager is a great service to store all that information, right? But because I'm not using database in this solution, so what I need to store the client ID and client secret. So I'm going to use a separate one, right? And as soon as you select that, the next option is going to be change accordingly. I'm storing the key and value pair, and these keys and value pair we can use at runtime to get the information back. So obviously key is going to be the label for my secret, and secret is gonna contain the actual value, right? I can also store in the plain format as well, but I will prefer the key value pair. And obviously we can even encrypt the secret information further using our own defined key, or we can use the AWS Secret Manager encryption key to encrypt that information, that if someone try to snag that information, it's not going to work for them because the information is going to be encrypted in the storage format, right? So that's the whole concept of using the secret manager. Just to cover the time of this video, I've already created the secret for this exercise, and I called it statistical JWT token. And guess what? This token is going to have 4 values. You can see domain URL, client ID, client secret, and scope. So these are all the values. Let me quickly jump back into my code. If you remember, let me see if I can make it bigger. Yeah, one big challenge in here is the screen space. I believe you guys can easily, how about if I can, yeah, I think that's much better. Apology for the small font. Yeah, I think that's way better. So you can see we have these 4 values, and I have created 4 secrets based on these 4 values, right? And at the moment, the domain URL, client ID, client secret, and scope are corresponding to these four values, right? Now, the next step, obviously, for me, because I've already created a secret, I need to replace these values with the variables that can contain the value from Secret Manager on runtime and populate these variables, which are further used into rest of the code for calling the JWT. So I'm not going to the rest of the code because you guys know that all the remaining code is gonna remain same, which we have discussed in last 9 videos. You can refer to those videos if you need to understand anything regarding the rest of the architecture or the solution, right? In this solution, we're gonna focus on getting the secret from a Secret Manager service. Now, in order to do it, we are introducing another package, Boto3, and you guys know if we are using Python, we generally use Boto3 to interact with our AWS components or services, right? Very common and very stable service to build the solution using the Python. Strongly recommended, and I believe if you are working in the AWS domain, you are familiar, and for some aspect, you have tried that library as part of your work, right? So it's pretty popular. So let me grab the code which we are going to use, and I'll explain that code shortly. So instead of, merging the code into my main function, I kept it separate. So what I'm going to do, let me just copy first half of it so I can easily explain to you. So you can see we are calling a get secret information. We are building a get secret information function, and it has the secret name, and that secret name can refer to the secret or the ARN. ARN is the unique identifier for all the assets that we generally create into our AWS environment. So every asset is uniquely identified by ARN. So you can see I've already copied this ARN, and just to show you where you can get this ARN, if you go back to your secret that you have created, it has the name, and obviously underneath it has the secret ARN. So you can see it's a pretty long raw text, but if you understand the ARN, you're going to understand how this has been built, right? So at this stage, we are not concerned on the construction of this ARN. The only thing I need that ARN to be used in my code. All right, so I'm using that secret name. By the way, we can also dynamically read it from the parameter of the Lambda function, but that's the discussion for the future video. And like I mentioned, in order to interact, we need to use the Boto library. And how we used it, we generally define an object, generally called it client, because we are going to set up an object on the Boto3.client. And in that client object, we will actually pass the service that we are trying to use. So it will return us the reference of that service. And obviously through that object, then we can access all the asset that has been defined, or all the functionality which is available part of that service. Coming back, and let me copy the next part of the function, which is obviously the actual mechanics or the architecture. I'm using the try catch so I can capture any exception occur during interaction with the Secret Manager. Just from the coding perspective, you guys know that we need to do it so we can capture all sort of exception. If you don't do it in here, it's gonna fail, I would say, not gracefully. You still get all the error information in the CloudWatch, but obviously your function is also gonna show you that, okay, the Lambda function has failed. But if we put a try and catch, at least our Lambda function failed gracefully. Like, it obviously throw the error, but the function itself completes successfully. So that's what I mean, fails gracefully, right? Which is a best practice once we develop functions or codes like this. Okay, so the very first thing you can see, I've already defined an object on my Boto library. The function is pretty straightforward. I'm going to call the get secret value. I would strongly recommend, if you are looking to work in the AWS, please go through with Boto 3. It is really a good, I would say, a library built in Python, and the documentation has been managed very well. So it will give you a very good idea how you can build solution using the Python library in AWS. So calling the get secret value, all I need to pass is the secret name. And if you remember, I mentioned secret name can be either secret name or the ARN. So I'm passing the ARN of my secret, which has the value stored in it, right? So once it has been passed, the response gonna have all the values which I'm expecting from my secret manager, right? So obviously you can see response is secret string. I'm gonna convert it into JSON, and I'm gonna store it into secret variable, which will return back to my calling environment. Pretty straightforward, right? The only thing what I'm doing, I'm just, instead of passing returning multiple values, I'm converting them into JSON, and then storing it in a variable and passing that variable back to my calling environment. Because JSON, if sending information in JSON, it will be easy for me to process that information instead of using multiple variables and receiving it on the calling end. That's a bit, I would say, ugly practice, not the recommended one, right? So I think our function, and if there is any exception, I'm still gonna return the JSON, you can see, but in this JSON, I'm just sending a random code and as well as the error description. So the calling environment gonna receive that JSON with the error information. All right, so coming back into our calling environment, if you remember, like I mentioned, I'm going to now call the secret in here, get secret information, and I'm not passing any information. And now once I have my secret in here, all I need to just replace these four values with the secret, right? Which I've already copied for myself for this video. These are all the static value, but you can see in here, I have these four values. So now I'm going to replace, and you can see the code looks much better because there is no static value, there is no secure information embedded into my code. And then I'm reading the values from the secret manager and populating the variables accordingly, and then the rest of the code will remain same. So that's the whole concept of using the secret manager and getting the information. And obviously, as soon as the function completes its execution, the information is going to destroy because it stays in memory, right? So we are not storing that information anywhere, so that information is going to be secured. All right, so let me see if I can just deploy my function with all these changes that I have made. Okay, the function is successful. I'm going to now hit test, and voila, have a look. We have the function working in a similar fashion as before, but this time there is no secure information hard-coded into my Lambda function. I'm using the secret manager to store the information and accessing it during runtime, right? So just to quickly test the capability of my function that it's all working fine, I'm just gonna change the source function and see whether if it's able to return me the results accordingly. So let's load the source function. And what I'll do, instead of 8, I will jump to one number ahead. Let me deploy. I'll first show you the results in here. So you can see 362.880. And now let me jump back to my secure environment. Sorry, my secure Lambda function. Let me hit test. And you can see we are getting the same result as we have seen in executing the Lambda function from its source location. So that's pretty much it, guys. We build this solution from end to end. Obviously not part of this video, but then I'm gonna now show you the in the future video what's the significance of using the architecture in the agile way of working, and how it can, you know, contribute in managing your coding timeline, and you know how it contributes in our daily stand-up. So that's the only piece which is remaining, which is obviously not the technical, but it's more like related to the project management, and that greatly help not only project managers, also with the architects and the dev as well, right? So feel free to put any comment or question if you have. We have successfully finished the end-to-end solution. I'm gonna put that code into LinkedIn as well as on the GitHub as well. I'll paste the link in the description later on. Once I publish that code, feel free to try by yourself. It doesn't require a big value. Tell you the truth, if you have a AWS subscription, you can try it with couple of cents. So that's how much it's gonna charge you, but at the end it will give you a very good experience in using the different services of cloud, and how it can help you to implement similar security into your solution if you are using AWS technology. Hope you like it. Feel free to reach out if you have any question. Otherwise, please like or subscribe the videos, and I'll see you in future videos. Thanks for watching.